We're going to soon be looking at the inverse functions of exponential functions, and we'll be introducing a concept called a logarithm. But before we get to that, there are a few things we need to talk about regarding radicals and exponents. Now, we've seen square roots before, but those aren't the only roots that exist. We can also look at cube roots, fourth roots, and more. Let's look at some quick examples. So here, we're going to look at the cube root of 8. We use the same symbol we use to denote square roots, but we put a small 3 in the upper left-hand corner to denote that we're taking a cube root. And so when we're taking the cube root of 8, we're asking what number can we cube and end up with 8? And the answer is 2. This is because 2 cubed equals 8. Let's look at another example. Let's look at the cube root of -8. So here we want to know what number we can cube or multiply by itself 3 times and end up with -8. And we couldn't take the square root of a negative number unless we were dealing with imaginary numbers, but we can take the cube root of a negative number when we're dealing with real numbers. And in this case, the cube root of -8 is -2. And this is because if we take -2 and cube it, we end up with -8. Unlike square roots, we are allowed to take the cube root of a negative number. Let's move on and let's look at an example of a fourth root. Here, we'll look at the fourth root of 81. In this case, we're asking what number can we raise to the 4th power and end up with 81. So basically, we're looking what number can we raise to the 4th power and end up with 81. And in this case, the answer is 3. If we take 3 times 3 times 3 times 3, that gives us 81. So the fourth root of 81 is 3. I hope you're starting to see how cube roots and fourth roots work. It will take a little bit of practice to get used to, because it's something that many of you haven't seen before. But once you go through several example problems, it should be not that bad. Let's do just one more example. Let's take a look at the fourth root of -81. In this case, we're looking for a quantity that we can raise to the 4th power and end up with -81. And unfortunately, there's no real number that satisfies that, because if we take a real number and raise it to an even power, we end up with a positive answer, even if we started off with a negative number. So we say this is undefined. Whenever we try to take a square root, or a fourth root, or a sixth root, or an even indexed root, the number up here is generally referred to as the index. Whenever we try to take an even indexed root of a negative number, the answer is going to be undefined, because in these sorts of problems, it's assumed that we're looking at only real numbers, and it's impossible to do this over the real numbers. Please take a look at some of the example videos linked below so you can get more practice dealing with cube roots and fourth roots and even fifth roots, because as we move forward, we're going to need to be very comfortable with these sorts of things.